Hi, this is Ruyi Zhang, and this is a presentation video for my course project, Implementation and Evaluation of Turbo Codes. This is a course project of EEL 6509, Wireless Communication of University of Florida. Sorry I got cold recently, and we'll be speaking slowly in this video. We use wireless internet every day, and we never thought of how it works, how to make it faster, or how to make it steadier. By taking this course, I gained more knowledge and more understanding of wireless communication and realized that wireless communication is now and will always be one of the most important technique in communication area. Wireless communication can be divided into a lot of aspects, such as analog to digital converter, signal transmitter, channel coding, transmission rate, and so on. Every aspect is important, including the coding theory, which basic purpose is to design efficient and reliable data transmission method. And here is a picture of a two-dimensional visualization of homing distance. In homing distance is a very critical measure in coding theory. As for the coding theory, there are four types of coding theory. Data compression, it's actually four types of coding. Code, data compression, error correction, cryptography, and line coding. Data compression is also called source coding, which happens before the data is transmitted. The main purpose of data compression is to reduce the data size, and the main challenge of data compression is to maintain the quality while compress the data as small as possible. For example, if we want to send a black image, instead of sending 0 a lot of times, we can transmit a special code to inform the receiver that this is a black image. The same logic applies to videos and other media types as well. Error correction can also be called channel coding. After we compress the data at the source of the transmission, what need to be done is to ensure we still got the right message after transmitted in this noisy world. On opposite of the data compression, we will reduce redundancy and try to reduce the size of the data. In error correction, we try to add some redundancy to make the data more robust and error tolerable. As for cryptography coding, it is about making the data secure to transmit. It translates the readable data into nonsense and only only the designated receiver can encrypt it. Especially in wireless communication, the data is transmitted around everyone, and if this data isn't understandable for everyone, there is no security at all. Line coding is designed specifically for digital signal transmission. It is based on the original data code with some modification. We use line code to avoid situation where there's a long sequence of zeros and ones, and the receivers may misunderstand this as there is an interruption of the transmission. So what we're concentrating on this project is error correction. For error correction, it can be divided into error detection and error correction. There are two ways to implement this. One way is automatic repair request, and the second is forward error correction. Which also in ARQ, error detection bit or bits is added to every data block, and if receiver detects an error or more, the data block will it will request another send time. So the sender have to send the data again. ARQ require less extra bits, and it's easier to implement. However, it do require more time to communicate between the sender and the receiver. While for FEC, the receiver not only detect the error information, but also need to restore the error data using extra correcting bits. And this is a simple example of FEC to transmit each data bit 3 times, which is also known as 3-1 repetition code. So for this code, we have a type of we have a type of possible output when the receiver receive this code. We can see if one bit is wrong, it can be corrected, but if it's more than one, it's not possible. The receiver in this coding will correct the data using majority vote. This does not ensure the correctness when the channel is really noisy, and that when you send a 1, the receiver may get 000 instead. So it's not the best way to implement this. And for FEC, it can be divided into a lot of types. Mainly are block codes, convolutional codes, and turbo codes, and other coding methods. And block codes work on fixed size block, and convolutional codes work on bit streams. Classic block codes are usually decoded using hard decision algorithm, which means that for every input bit, the receiver must decide it is a 1 or a 0. And on the contrary, convolutional codes are typically decoded using self-decision algorithm like the Viberti, MAP, and the BCGR algorithm, which process analog signals in which allows for much higher error correction performance than hard decision decoding. So the basic idea of turbo codes is to use 2 convolutional codes in parallel with some kind of interleaving in between. And the structure of the system is shown in this slide. We can see it consists of 2 encoders and the interleaver to interconnect those 2 encoders. And the encoder can be divided into convolutional encoder and interleaver. The convolutional codes are introduced in 1955 by Peter Elias and is widely used in a lot of applications since then. It is similar to the old convolutional we've learned, using several memory registers and mode 2 adders. Each adder has an output. This picture on the slide is a simple example of rate convolutional encoder with 3 registers, 3 adders. Constraint length is 3, and generator is G1 equals to 111, G2 equals to 011, and G3 equals to 101. And so the convolutional encoder can actually be divided into a non-recursive and recursive. And recursive encoder includes feedback in the system as shown in this slide. And then we move on to interleaving. Interleaving is a technique used in communication systems for burst error correction. Interleaving ameliorates this problem by shuffling source symbols across several code words, thereby creating a more uniform distribution of the errors. Here's a simple example of interleaving. We assume burst error gaps as 4 symbols in this example. So we have contiguous 4 digits missing in this message. Okay, let me see my mouse. Can't get it. The transmission without interleaving, you may get the C right because you got 3C out of 4, and the D you may not get it right. And after we interleaving it, in the lower pic image. Even if we got a transmission burst error, we still got every uh, every letter right. Um, Use of interleaving techniques increases total delay. This is because the entire interleaved block must be received before the packets can be decoded. Also, interleavers hide the structure of the arrows. Without an interleaver, more advanced decoding algorithm can take advantage of the arrow structure and archive more reliable communication than a simpler decoder combined with an interleaver. So the decode of the turbo code can be designed in a similar way as we designed an encoder. We need two elementary decoder connected to each other in serial, not like the encoder. We arrange them parallelly above. The structure of the decoder is shown in the left image, and the SK, YK received by the decoder as in the right image. And here's are the results I got from the I used the MATLAB to provide a library to implement the turbo codes and got the following result. Okay, now it's time for demo. We will run it for the six iteration number and 512 block lengths. We can also just change them and got different results. This is initial the encoder, and this is the noise, and this is the decoder. Okay, here we are. We got the turbo code results. And the rest are similar to each other, so I won't be running other demos. I use random input data and display the BER with different iteration numbers and different code block lengths. The turbo code is an important channel coding method which push the wireless communication into another level. It is the first coding method that closely approach the channel capacity. It is used in 3G and LTE. This technique has already been simulated and used in real life, though it still has some fallbacks. It is far more complicated than just the convolutional coding. It involves iterations and more complicated decoding method. The algorithm is complicated and time delay needed to be shortened. Despite all difficulties, turbo code is being widely used as a channel coding method and will be more and more perfect during this process of use. Thank you for watching.